Hello friends, this video on P-block elements part 1 is brought to you by examfear.com. No more fear from exam. So objective of this lesson is to learn the general trend in the P-block elements. You have to understand the physical and chemical properties of group 13 and group 14. Please note, we'll be taking only group 13 and group 14 in this chapter. We'll understand the special behavior of boron and carbon. We'll define the allotropes of carbon. And we learn some important compound of boron, carbon and silicon. We'll also list some uses of the group 13 and group 14 elements and their compounds. So this is what we'll cover in this chapter. So let's start with the first question. What are p-block elements, right? So the p-block elements are nothing but the elements in the periodic table whose last electron enters p orbital. Please note, the last electron enters p orbital. So if you see, this is the periodic table. The one in this side, little orange in color, these are my p-block elements. And if you want to zoom this, the p-block elements are nothing but the boron family, the carbon family, the nitrogen family, oxygen family, fluorine family, and the this gas, noble gas. These are my p-block element, that is group 13 to group 18. We'll discuss more about the p-block elements in the next few slides and understand that p-block element nothing but group 13 to group 18 elements. And why they are called p-block elements? Because the last electron enters p orbital. We'll discuss more about this in the next few slides. But before we go through this chapter, let's understand why should we study p-block elements. What are the applications of p-block elements in our day-to-day life? So if you see the coal, which is used extensively to produce electricity in the villages, it is used to produce. It is used in the stoves to cook food. Right? This is nothing but a p-block element. It's carbon. You see the diamond itself, which is used to make ornaments. It's very costly. This is also p-block elements, and actually this is also carbon. The combination of coal and carbon is same. We'll talk about these later. If you see antiseptics, again the p-block elements are used to create antiseptics. If you talk about the pressure cookers, aluminum is used here. If you see in the extraction of metals from the ores, a lot of p-block elements are used. The aluminum foil, which you must have seen, right, to wrap food, this is nothing but a p-block element, is aluminum. In tires, we used p-block elements to vulcanize the tire to make it hard. We'll talk about that. Urea, if you see, to create urea is nothing but a fertilizer, and this feeds a body. It is a reason why we have so much food, because this helps to increase the output of wheat and rice, vegetables. This is also made from p-block elements. If you see the racket which we use to play tennis, these wires has to be hard, right? These wires which has to be hard. So here also my p-block elements are used to make this wires hard. If you see the pencils, earlier the lead was used, now the graphite is used here, right? And they are also p-block element. In fact, the lead was also p-block element, and the graphite is also p-block element. The lead is not used because that is harmful, and graphite is not harmful, so graphite is used. The utensils which we use in our home, the steel utensils, they are also made up of p-block elements. The paints which we use to color our homes, they are also made of p-block elements. The fire extinguisher, chips, it's a very critical thing. The chip, this is the reason why we have mobile phones, laptop, computers, iPad, fan, desktop, washing machine, fridge, TV, any electronic gadget you think of that has this chips, and these chips are made of silicon, and they are nothing but p-block elements. So this chip is something which has revolutionized the whole world. Actually, it has given a lot of comfort to us. If you talk about the air conditioning, or you talk about the refrigerator, you talk about the music system, you talk about the iPod, iPad, everything is made of silicon chips, and these are nothing but p-block elements. Human being itself, you see, we have a good amount of carbon dioxide and other p-block elements in this. I mean, this is critical for us because if you see, right, we take oxygen and give carbon dioxide. So carbon dioxide is nothing but carbon is a p block element. So p block element is there in our body itself. The battery, you see, earlier here also lead was used, but now graphite is used. Here also the p block element, carbon is used here. The wires, the heavy wires are made of aluminum because conductivity is more. So here also if you see the p block elements are used. If you talk about the pot, the porcelain, there also p block elements are used to create this. If you talk about the nuclear reactors, if you see the nuclear reactor, p block elements are used to control the speed of the neutron. So if you see p block elements are everywhere. If you talk about electricity, it comes from coal. If you talk about jewelry, if you talk about the batteries, if you talk about human beings, if you talk about computers, if you talk about washing machine, everywhere we have p block elements. You talk about the tires. In fact, p block elements were also used for anti-knocking agent in the cars, diesels and petrols. So if you see p block elements are everywhere. So that is the need. There's a need for us to understand these p block elements, right? Because we use them extensively everywhere, from the kitchen utensils to the paints. A lot of places we use it, right? So it's good to understand these p block elements so that we can understand the behavior of this p block elements. So let's start with the properties of p block element. As I told, the last electron enters the p orbital, and if you see the p orbitals looks like this. So we have 30 days in the atom chapter where we have talked about the orbitals, the shape of the p orbitals, and if you don't understand these p orbitals, please watch my videos on the atoms where we discuss these shapes and size of the p orbital. If you see, the p orbitals can accommodate at the max 6 electrons, right? One here, one here, one. So 6 electrons it can accommodate, and that's why we have 6 groups there in the p blocks, correct? So if you see, the p orbitals can accommodate 6 electrons. And thus we have 6 groups, group 13 to group 18. This first electron, second, third, fourth, fifth, sixth. Right? So there are 6 electrons which a p orbital can accommodate. So we have 6 groups for p block elements. It's a very good question actually, why we have 6 groups for p block elements. For example, if you see for s block we had 2 groups, right? Group 1, group 2. Why? Because the s orbital looks something like this, and it can accommodate at the max 2 electrons. So it had 2 groups. When we talk about p blocks, p orbitals is like this, right? 3 p orbitals we have, px, this is py, pz. 3 p orbitals we have, and these 3 p orbitals can accommodate at the max 6 electrons. So we have 6 groups. And the electronic configuration of the p block element, the general one, is ns2 np126. That means the p can have value 1 to 6. For example, it can be ns2 np1, it can be ns2 np2, or ns2 np3, or ns2 np4, or ns2 np5, something like that. You can have any of the value, or ns2 np6 also, right? So because this is 1 to 6 means it can have any of the value. Write a general configuration. We wrote the general electronic configuration for a p block element is ns2 np6. If you see here, the last electron is entering p block, p orbitals, and that's why it is p block, correct? And the good part, you see in the s block we had only metals, but the unique part of the p block elements is that we have metals, we have non-metals, and we have metalloids also. We'll talk about this. If you see, the boron is a non-metal, the aluminum is a metal. We'll talk about these metal, non-metals, and metalloids in the next few slides. But just understand that in the p block elements, we have all metals, non-metals, metalloids, all exist together. This is a unique property that we have all metals, non-metals, and metalloid in one block. And there is a lot of variation. If you see, when I'm saying that we have some are metal, some are non-metal, some are metalloid, it clearly means there are a lot of variation in the physical and chemical property in this group, right? Because some becomes metal, some is non-metal, some gives some oxides have acidic behavior, some have basic behavior, some are neutral, because some are metal, some are non-metal, right? So the metallic property varies, and thus the physical and chemical properties varies a lot in this group. There's a lot of variation in the properties, physical and chemical properties. It will be good and understanding, interesting thing to learn here. So hope I have cleared all these things here. It's called p block because the last electron in the p orbitals. So in p orbitals we can accommodate the max 6 electrons. So there are 6 groups, 13 to 18. The general configuration is ns2 np 1 to 6. And the best part of this group is we have metal, non-metals and metalloids all exist together. And there's a lot of variation in the physical and chemical properties observed in this group. Correct. Also, there is a good thing observed is, it is there in S block also. The first member of the group have different property than other groups, other members. I think in S block also we have seen the first element, they had different properties as compared to other. For example, lithium and beryllium, you see the S block had different chemical and physical property as compared to other elements, for example, sodium, magnesium, all those elements, right? So why? Because they have small size. Because there is small size. The main issue is the small size, and this is almost universally applicable. The first elements, they have different property than the other elements of a particular group, mostly because of small size. So these guys have different property. They are special. Let's see how, before we start the p block elements, let's see how they look. The boron looks something like this. The aluminum looks like this. You must have seen this. Gallium like this, indium like this, carbon is like this, the nitrogen is a liquid form, right? Oxygen also liquid, fluorine is like this, and all this the noble gas looks like this, the bromine is a liquid thing, right? Chlorine also liquid, sulfur is a solid, phosphorus also solid. So if you see, the property varies, right? Some are solid, some are liquid, some are gaseous. So this is how they look actually, all these p block elements. If you want, you can pause the video now and you can look at how they look actually. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.